Hello and welcome to another Network Wizkid video. In this video we will focus on how to configure site-to-site VPNs on Cisco IOS as well as Cisco IOS devices. This video is part of the CCIE Security Labs with Kelvin. If you've not checked out my other CCIE Security Labs with Kelvin, please do check out those on my YouTube channel. They should be in a playlist and easily accessible. So what we'll do is we will start by going through the presentation where we'll just cover some points related to site-to-site VPNs, and then we will go into the lab and do a demonstration of how we can actually configure site-to-site VPNs on ASAs and Cisco IOS. Now the purpose of this is to aid you with your CCIE studies against the blueprint topics, and not primarily to cover every little detail in depth. I'm assuming that by studying the CCNP security and working towards your CCIE security lab, a lot of the in-depth knowledge or the theoretical parts you should have down in detail. So these labs are really to give you a view of how to configure elements, especially for those that don't have lab environments so they don't really have the ability to configure these things in a lab environment. So starting off with a couple of main points with site-to-site VPNs. Many site-to-site topologies do exist. We're going to be focusing on point-to-point or P2P today, and that's why that's highlighted in bold. However, we do have different topologies such as hub and spoke deployments, maybe using DMVPN, or also full mesh deployments that can make use of DMVPN. And we also have a number of ways to configure depending on the use case that's being used. So you can see I've got a few different ways that we can configure these topologies based on what it is that we're trying to achieve. So we're going to be again focusing on point-to-point today. So we'll be configuring P2P tunnels. We'll be maybe looking at FlexVPN, DMVPN, and GetVPN in upcoming lab sessions. In terms of configuring site-to-site VPNs, the configuration steps are pretty straightforward. So there's more to what you see with regards to configuration, but in terms of steps, we start off by configuring the IKE Phase 1 security associations. Then we'll go on to configure transport sets, and then we'll configure crypto ACLs for the interesting traffic. And by interesting traffic, what I mean by that is the traffic that needs to be encrypted and sent across the tunnel. And then lastly, what we'll do is we'll configure what we call crypto maps, and then we'll apply that or configure that to be applied to a certain interface. And that's going to be the outside interface that's going to be used to send that traffic across the tunnel to the other side of the tunnel. So we'll take a look at that in a little bit more detail, but that's the basic steps for Cisco IOS VPN configuration. Now I haven't covered the ASA steps because there's a few ways we can configure that, whether you're using ASDM, which is a graphical user interface, or whether you're using the CLI. But more importantly, I haven't really covered that in the steps here because a lot of them are fairly similar. However, I just wanted to really go through that in our lab to show you the differences between the two as opposed to just having them down on a PowerPoint. So with that said, as you can see here, this is going to be our lab environment for our demonstration today. So on the left hand side we have what we call the HQ. That's this left-hand side box here. So you can see 192.168.10.0 subnet/24 in the HQ. So we just got a virtual PC just to test, and that subnet to which VPC2 is actually on will be used as the interesting traffic to send across the VPNs. And you can see we've got an ASA here, so we'll configure a point-to-point VPN with the branch and the partner, or one of the two, and show you how sort of we can build a VPN between ASA and iOS point-to-point VPNs. And similarly, what we'll do is we'll also do like for like, so we'll build a point-to-point tunnel from our partner to our branch and vice versa, so that we can see how that's done. And then we'll also do some verification checks from VPC3, VPC4, and to make sure that everything is working as it should be. So I will leave that one up, but without further ado, let's get up into our lab environment. So our lab environment is partially configured. So what I've done is I've made sure that the basic configurations are in place. I've verified connectivity with regards to the VPCs, making sure that they can reach the gateways. But what we can do is we can see here, if we just up arrow here, you can see if I ping the gateway here from VPC2, which is on the HQ. So that's pinging the ASA, that's successful. And then we can also do the same now for the other devices. So VPC3, again, if I just do a ping 0 and 0, oops, 1. Again, you can see that that's successful there. And then lastly, if we just do a ping from VPC4, which is 192.168.20.1 is the gateway, again, you can see that that is also successful there. Now, just to make sure that nothing else is in place, we can try to attempt to ping, let's say from our branch VPC4 here to our partner PC, which is 10.0.10.100. And you can see there that that destination is unreachable. So once we build that VPN tunnel between the two sites, we should see that change. And if we just go back to our other one, I think it was this one, VPC3. Again, if we just do similar and try to ping branch VPC4, 20.50, we can also see that that is not successful either. So what we'll do is we'll start off by configuring a point-to-point tunnel between our partner and branch. So to do that, we need to start off with, let's go for router 5, which we can see here. So again, it's just got the basic config on, you know, nothing special, just IP addresses there you can see. And that is literally it. It doesn't have anything else on there. So we'll start off by configuring our point-to-point VPN. And to do that, what we need to do is we'll start with the phase 1 configuration. So we'll do crypto ISA KMP policy, and we'll create a policy, and you can give it a number between 1 to 100,000, as you can see there. So we'll just call this crypto IC KMP policy 10. And then what we need to do is we need to set our hash algorithm lifetime group, our authentication method, as well as the encryption. And a nice easy way to sort of remember the configuration that takes place in phase 1 is to just think of the word haggle. So H for hash, A for authentication, G for group or Diffie-Hellman group, L for lifetime, and E for encryption. That's the way I sort of learned to remember it. So if we just went through and type now H, you can see hashing, and then we can select our hash, preferred hash there that we'd like to use. So we'll do SHA-256, and then we can say authentication. And again, we've got a few options here. So we can use signatures, we can use RSA encryption, or we can use pre-share keys. So we're just going to stick with the pre-share key method. And what we'll also do then is we'll set our group, our Diffie Hellman group, and we'll keep this at, let's do Diffie Hellman group. Let's do group 19. Or what's group 5 there? Yeah, let's just stick with group 19 for now. We can always change it if we need to. And then we'll create our lifetime or a timer for our IPsec AMP policy. And this is usually set to 86400, which is 1 day. And then what we'll also do is we'll set our encryption lastly. And you can see we've got 3 different methods on here of this particular version of iOS. So we're just going to say AES and then we'll select 256. So that's our phase 1 configuration done on the partner router. We also need to make sure that the branch router, so router 6, also has the same configuration. So we won't do that now. What we'll do is we'll just continue with our configuration to complete this on our partner router, and then once we've done that, we can then go over to our branch router and finish configuring that. So what we'll do now is we will, once we've done our phase 1, what we can do now is we can actually set our access control lists for our interesting traffic or our crypto ACLs, if you like. So to do that, we'll just create an access list. So access list, and we'll say 110, and we're going to permit IP. So we're going to basically permit traffic from our 10.0.10.0 subnet, and then we'll do the wildcard mask for that. Then we're going to permit that going to 192.168.20.0, and again we'll put in that subnet mask there. So that's our crypto ACL, which is defining that interesting traffic. So our interesting traffic is from the partner network of 10.0.10.0/24 to our branch, which is 192.168.20.0/24. Now with that done, what we can do is we can actually create our transform set. So we can actually do our crypto IPsec, and then you can see our transform set, which is going to be used, or is basically telling the device how to set up that protection. So once we've done that, we can then give this a name or a tag if you like. So we'll call this transform in capitals. Transform, yep. Oops, we've not completed that. And now what we're going to do is we're going to select our encryption. So we're going to use, you can see we've got a few options here: authentication header, or encapsulating security payload. So what we'll do is we'll do ESP AES, and then we're going to do ESP SHA, and we'll do HMAC. Okay, that should be sufficient. So we'll just keep it simple with that there. So we've done our transform set. Now once we've done our transform set, what we need to do is we need to create now our crypto map. So if we do crypto, when we come out of this actually, because we've done our, just make sure, yeah, so we'll just exit out of that. And then what we'll do is we'll do crypto map, and then we give our crypto map a name. So let's just call this, let's do crypto map 10. Let's say, for example, and we might create some more depending on what we decide to configure in this lab. And then once we've done that, what we can do now is we've got a few options here. So we need to select IPsec, which is not there. So what we'll do is, in fact, what we first need to do is we need to select our crypto ACL that we did. So we need to do 1110 for that. That's the ACL number that we did. And then now we can actually do the IPsec KMP, which is specifying what we're using. And then once we've done that, we can actually go in now to the configuration, and we'll say match address 110. So that's going to match that crypto ACL. And then we're going to set our transform set to what we created. So we'll give that same name again. So transform, make sure that matches. Now we need to set our peer. So if we think about our peer that we've not yet configured, our peer address is actually going to be the public facing IP address of that branch. So that's going to be 209.209.209.10 in this instance. And then what we need to do is we need to set the security association, the lifetime in seconds, and then we'll do the same time, 86400. And then once we've done that, we are pretty much there. So we can exit out of that, and now we just need to apply that crypto map that we've just created to our external facing or public facing interface on router 5. So what we'll do is we'll go into interface heap 00, and then we'll say crypto map, and then crypto map 10 is a crypto map that we created. So if we now do, so now you can actually see there that ICKMP is being turned on now for that interface. And if we exit out of that, and if we just do show crypto ICKMP SA, we don't have no security associations yet because we've not built that tunnel there. But if we have a look at policy, you can see the policy now that we have created for this specific ICKMP policy. Get that a little bit tongue twisted sometimes. And same with show crypto IPsec. And if we have a look here, we can also have a look at the policy, the profile in this case. We can also see our profile that's configured there as well. And we can also, once we've got that security association configured, we'll also be able to see our in-caps and decaps to show that traffic's flowing across this tunnel successfully. As you can see, it's all 0 at the minute. Everything's 0 at the minute, but you can see that based on our configurations, we've got our remote identity, our local identity, which is that interesting traffic that we want to apply or send through the tunnel, essentially. So what we'll do is we will now complete the same configuration on router 6, and I think it's worth, actually, for the sake of this video, we'll just go through the whole configuration again, just so that we can see how it's done again. And once we've done that, we'll try to verify traffic between our branch and our partner site as well. So let me get the right device up. So this is router 6. And again, it's just got basic configuration on, but now what we're going to do is we're going to configure the, again, with the ICKMP policy. We'll give this 120. And then again, we'll set our hash algorithm, and it should all be the same. So we said SHA-256, 256, authentication, we'll do pre-shared. And what we'll do is group, did I say group 15? No, I said group 14, I think it was. Lifetime was 86400. And then encryption was AES 256, we said. All right. So what we'll do now is, again, we'll go on to our crypto ACL. So we'll do access list. We'll call this one 120. permit IP, and this time it's going to be the reverse IP, so from the actual site itself, so 192.168.20.0, the wildcard, to 10.0.10.0, and the wildcard mask there again. So that's going to be towards the subnet of the partner site. So we've done that now, and again, as a reminder, what we can do now is we'll create our transform set, and again we need to give it a name, so we'll call this transform just to keep things simple, and then we'll specify ESPAS again and ESP SHA-HMAC. Okay. Let's exit out of that. And now what we'll do is we will configure our crypto map. So if we say crypto map, again, we'll give this we did crypto map 10 for the last one. So we'll say crypto map 20 and 120 for the access control list, the crypto ACL that we just created. And then we'll do IPsec, CKMP, and we're going to match address 120. We're going to set our transform set as transform. We're going to set our peer. This time it's going to be the public facing IP address of the partner site. So this will be 209.209.209.6 as our peer. We'll set our security association lifetime in seconds as 86400, and let's just make sure we're not missing anything else. One thing that we do, that should be good actually for that, but one thing that I did miss actually that we do need to set is our pre-shared key. So we need to do crypto ISACAM key. Yep, key, and then let's just give it a key of Cisco for our address, which is going to be the P address. So I'm on router 6 this time, so it's going to be 209.209.209.6, and we need to do the same for our other device that we just configured before this will actually work. So crypto ICKMP key, and we'll say Cisco. Them keys will match on each side, and then we need to set our peer, which is going to be 209.209.209.10. And the last thing we need to do on router 6 is to actually map that crypto map to our external interface now. So we'll just do interface Ethernet 00 crypto map, and then it's crypto map or CM20 I think we configured, and there we go, we should be good now. So if we just do show crypto ICKMP SA, we don't have any SAs at the moment, so let's try to generate some traffic, and let's see now with all that configuration in place what results we get. So I need to head over to VPC4, which is here, and if we just up arrow, we're going to try and ping VPC3 now, and let's see what happens. In fact, before we do that, let's just make sure that we can actually reach from router 6, we can actually reach router 5's external interface. So if I say do ping 209.209.209.6, you can see there that we can't reach the 209.209.209.6 from router 6 because we need to put in a route. So if you have a look, do show IP route, you can see that we have no default route. So if we just do IP root 209.209.209.4 with a wildcard of 0003, and we're going to go via 209.209.209.9. Is that inconsistent? It should be. Let me just double check. Okay, it's going to ask for the prefix mask instead of the wildcard. So let me do 252 and 209.209.209.9. That's better. Getting confused with the different syntax that I've been using more recently, but that's fine. So if I do show IP root, we can see now that we've got a static root, which should now work. So now if we just do ping 209.209.209.6, we also won't still get a reply because we need to configure router 5 as well. So let's just get root in router 5 as well, so it knows where that return traffic's going. So if I do IP root anything going to 209.209.209.8, 252, we're going to go via 209.209.209.5. All right, so let's give it a go now. There we go. So now you can see that that's successful. And vice versa, if we just do ping to our branch site, 209.209.209.10, we can see that that's successful now. Brilliant. So now we should actually be able to do show crypto IPsec SA. We see we don't have anything yet, but now if we go to our VPC4, which is on our branch site, and we try to ping VPC3, let's see what result we get. Okay, that's still unreachable. Let's just have a look at the security association. Let's just quickly verify our configuration. Just make sure everything is in place as it should be. So we've got our IC KMP policy there. We have our key, our pre-shared key for our peer. The IP address there is correct. We've got our transform set configured, and we have our crypto map configured, matching against our crypto ACL 120. We've got our peer set. We've got our crypto map applied there to our interface. And then we have our crypto ACL. So we're permitting 192.168.20.0 to 10.0.10/24. So all looks good there. We can see both interfaces are up, so we're good on that front. Let's have a look at router 5. So again, we've got our crypto ICKMP key, which is correct. We've got our policy. We have our transform set. We have our peer set for our crypto map. That's correct. We've got our association transform set, as well as our matching IP address for our crypto ACL 110. We've got our crypto map applied to our outside interface. And then we have our access list 110 from 10.0.10.0 to 192.168 20.0. So everything looks good there within the configuration. So what I'm just going to do is I'm going to quickly just reboot both of those VPCs, because I have had a little bit of an issue in my NG environment where I leave them on for too long and they all of a sudden just stop working. So I'll quickly reboot them and then we can do another test and see what results we get once we've reconfigured those as well. All right, so now they're configured again. Let me just double check by trying to reach the gateway first. 192.168.20.1 on VPC4, and that looks good. And then let me try as well on VPC3, which is from the partner site. And again, we'll reach the gateway, and that's good. So now what we'll try to do is ping again 10.0, 10, 100. And we still get this same destination unreachable. Let's double check our router 6. Actually, I've already picked up the issue because I didn't put a default route in. I just created a static route to each of the routers. So what I'll do is do an IP route, a default route to our next stop. So from router 6, we're going to go to 209.209.9. And then what we'll do from router 5, always check the default routes. What we'll do is from route 5, we're going to our next stop, 209.209.5. Now it should be good. This should theoretically work now because now I've got the default routes in. Let's see. All right, so now we're getting timeouts. Let me just try that again. All right, so we're getting timeouts from that. Now let's do from VPC3, which is on our partner site. Let's try to ping 192.168.20.50. All right. So now you can see we've got a failure here. Failed with P at 209.209.6. So this is the router 5. And now we can see on router 5, we can see that we failed with P 209.209.209.10, which is router 6. And you can see that we've got a IKMP mode failure, processing of informational mode. So let's just have a look at what that is. I am a little bit skeptical all the time because I am using virtual devices, so that could be a bug with the device itself, but let's just take a quick look. So the first thing I want to do is actually let's just do show run include IC. I'll just begin just so that we can check the policies that we created. So group 19, I just want to make sure that everything matches up. So you can see here we're using two different groups here. So we're using group 14 on this device and group 19 here. So this is most likely going to be the reason here of the issue. So let's just quickly change this policy here. Crypto ISCAM policy 10. And it's always good when we get some live troubleshooting in as well, because you can actually see the process I at least try to follow to try and rectify issues that I see as well. So again, you can see group 14 being used here for defilement, and we can see group 19 here. So if we just change this to 14, and let's just do a check just to make sure that that's changed there. So yeah, you can see. Now let's just try and ping again now. And now you can see that that's successful. So you see the issue there was with the ICKMP policies that I configured. I just configured the wrong defilement group. They need to be mutual on each side. They've got different groups or different configuration, and you're likely going to see the issues as we just saw there. So just before I test on the other device, the first one timed out because that's while the tunnel is being built. The security associations are being set up between the two peers, and then you can see the rest are successful. So if I now attempt to ping again, you can see every single one of them will be successful. Likewise, if we try ping from the other side, so from our partner to our branch, now that the security association's up, we can see that that's successful straight away. Brilliant. So now if we just check our router 6 verification commands, so if we just do show crypto IPsec SA, you can actually see now that we've got our security association showing there. So we can see our destination, we can see our source, and we can see the status which says active there, which is brilliant. And this is from router 6, so this is from our branch site. And also if we do show crypto IPsec SA, you can see now where you had no encrypts and decrypts before, we can see that we've got encrypts and decrypts here, which shows that our traffic is going through our tunnel, and we've got the relevant information there as well. So those are just a few commands. You can also see that we've got our inbound ESP SAS, and we've got a status of active, and then we also have our outbound one as well. And you can see a few more details here. That's our transform sets that are being used. We can see that it's tunneling. We can see our security association remaining key lifetime that we configured, so you can see that changing as well. So there's some good verification output. You can see it there to determine and show that everything is up and running as well. Brilliant. So that's how we can configure IPsec point-to-point tunnels using Cisco IOS devices. So pretty straightforward to configure, and you also got to see some basic troubleshooting around IPsec VPNs there based on the configuration that we configured. So I hope you found that useful. In our next video, we're going to use the same topology, but rather than configuring between two Cisco IOS devices, we're actually going to configure a point-to-point tunnel between the ASA and the Cisco IOS device. So we'll maybe look at doing that from the HQ ASA to the branch device as well, and we'll verify that our configuration is successful and both devices behind the ASA and the router both can communicate with each other as well. So I'll see you in the next video. Again, I hope you found that useful. If you have, please do like, subscribe, leave a comment to show your appreciation if this has helped as well. But until next time, thank you for watching.